something that we talked about in this call earlier has been implemented. It says EIP. It's EIP 6049. It's pretty simple, so let's just take a quick look at it, talk about why we did it, and then see how it got implemented. So here it is. So this is an Ethereum EIP. That means we want to change something with how Ethereum works. And the proposal is to deprecate self-destruct. Self-destruct is one of the actions that a smart contract can take. It's a opcode, and the opcode results in the contract being removed from the blockchain, its functionality being destroyed, and then whatever ether it has being sent to a specific account. This used to be called. We don't use that word anymore. Now it's called self-destruct. Self-destruct has some very specific, important characteristics that are difficult to implement. They're so difficult that the people that make Ethereum have decided that we don't want this thing. For example, it changes a lot of storage, and that's dangerous because the gas cost for this action is very small. It's a finite amount of gas. However, the amount of storage that is changed is arbitrary. Whenever you have a situation like this on a blockchain, there's a risk they're going to do so much change that it's going to require the clients to rescan their hard drives to keep up, which might not be done within 10 seconds, which means the whole network is at risk of a fork or a fork attack. And you don't want that. So the solution is to just get rid of it. They want to get rid of self-destruct. They want to stop it from happening. Also, one more risk is that because now we can put smart contracts at specific addresses, we can deploy a smart contract, destroy it, and then put a different one in the same place. Watch out for that. All right. People don't like this. We've identified this risk. We've known about these risks for years. And the solution is pretty simple. Before we would implement something like this in Ethereum, and this is a consensus change, we really want to study this because we are screwing somebody, possibly. Maybe they're depending on this. The consequences could be dire. So we really want to understand this. We don't think there's any problem. But again, we would rather study this for 3 years and not have a problem than study this for 2 years and one person gets screwed over and wasn't expecting this. In the meantime, everybody agrees that we should stop using this going forward. I found this as an opportunity. Well, we should write that down and we should pass that. The EIP is we should deprecate this feature, which means we should warn people before using it and tell people this is probably going to change. So it's your fault if you use it. If something bad happens, we're not going to care about you. It pretty well describes the consensus. The people that make Ethereum think this is the way to go. Nobody really disagreed with this. And so it was passed as final. So this is a final EIP. And then it was implemented pretty quickly in Solidity. So Solidity version 0.8.18 came out, had support for Paris hard fork, and then there it is. Self-destruct is deprecated. You're going to get a nice yellow warning. And now you can't say nobody told you when you use this, and then 3 years from now, we turn it off.
And people have been talking about that for a while. I wonder if there are other things like this where there aren't any warnings yet.
It is the price of storage. So this would be S-store, S-load. This is a very important pricing mechanism, and we've had some changes. This was studied a lot, and the problem was that the gas price specifically was programmed into everything. Everybody's expecting a specific gas cost. This is a big change. Things that were really expensive became really cheap, and people were expecting that cheap things, were safe, and expensive things were dangerous.
I have a question. You said that when someone uses self-destruct, something else could take its place. How does that exactly work? Would it have the same contract address?
This is dangerous. So when you create a smart contract, the way that the address is chosen, the normal way, is based on who created it and then the nonce. The nonce is the nth transaction that you created. This is a nice, predictable way. We were too cool for that, so we came up with a new way to choose addresses, and this is called create to. So you can kind of drive a specific address for deploying a contract. There's some benefits for this. So the problem with the nonce approach is that you might have 5 contracts that you want to deploy, and they're going to be at these 5 addresses. But it also means that if you want to deploy that address, in the meantime, you're not allowed to do any other transactions. So people had some ideas that for counterfactual reasons, where there might be a threat of deploying a contract at a specific address related to a time lock or a channel or a side chain or something like that. So there's a legitimate complaint against that approach, that that's not efficient, specifically for side chains, roll-ups, things like that. So they came up with Create 2. No matter what, we're going to deploy at this specific address. I can do it now or later, and I don't have to wait any transactions to do that. The bad part of this is that if the contract is deleted, the same contract can be deployed at the same address. The same contract deployment code will wind up at the same address.
Proxy?
So the contract deployment code uses a proxy. The proxy points to different things, and then the code is deployed. You can kill the contract and then deploy a new contract at the same address with different code.
That's insane. Have you seen anyone like take advantage of this to scam someone on Etherscan, for instance? You can upload your code and it'll say it's verified. If you delete it and upload a new one, would it still say that it's like verified?
That is a great question. So we're going to put that in the notes. We should test that.
So instead of burning an NFT, can I program it to self-destruct and it's just gone, just wiped out?
Yeah. So this is actually early implementations of NFTs were using smart contracts as one of ones. And then they could just self-destruct. That would be a burn. Nobody has done this because these things are so old and rare. I actually have this. So I looked at every single smart contract from the beginning. And then I found the first NFT and I actually stole it. I could just steal it. So now I own it. Now there's this thing. Anybody can steal it. So, I mean, I talked about it, and whether you think it's an NFT or not, that's up to you. But so I just took it. But the thing is, like, when you own it, you can actually destroy it. So anybody could just take it from me and destroy it. And that would be a nice troll, but nobody's done it. Possibly because they're too lazy, or possibly out of respect for the oldest NFT on Ethereum.
Yeah, I don't think anyone knows what you're talking about. So someone can take something from your wallet without accessing your wallet for this particular asset?
I mean, take it from your wallet. Those words are...
Is this smart contract inside or assigned to a particular address?
This contract has an owner.
And I could be said new private key owner with my private key without having access to your private key?
That's right.
Of that asset?
Yep. And then so now you can be the owner.
Cool.
So it's a good troll. And if you're the owner, be careful because you can actually destroy it if you want, which no one has done.
So if this measure gets passed to change the behavior of the self-destruct, will that effectively preserve your asset?
Oh, it will. That's right. So it won't be deletable. Wow, that's a good point.
No, stop pretending like this wasn't your plan. This is why you wanted passed.
See? Working in self-interest. This won't stop other people from stealing it from me. It'll stop them from deleting it, but it'll still be stealable too. All right, so what's good with Soulbind?
Thanks for having us, Will. A product that we're building that's called Soulbind. It's soulbind.app. And we also have a lot of questions for you. We tried to condense it to some of the most pointed ones. And we did actually watch, you had another really great community service talk specifically about soulbound tokens as a whole. Watched that, it was awesome. It actually brought up some more questions for us because we're seeing conflicting things within the community, and we'll cover that in a bit. But the first one on our list is really like, should there be a standard for soulbound tokens? A lot of people that are working in the space are basing it off of 721s, and they're building on the back of the 721 standard, which I think is great for just usability and composability. But I also wonder, should there be a standard for soulbound? I think a lot of people, when they first see soulbound, the initial thought is that, well, it's just a 721 token with transferability removed. As we've been digging into the space and talking about use cases with our customers, we're finding that there's more to this that could potentially be standardized, but we're also trying to draw the line on like, what do we standardize or should we standardize, and what should be just at like a product level as well.
Obviously, people are already doing this. People are implementing this, and the word soulbound token, I think, was popularized by Vitalik recently, last year. And otherwise, we just called them NFTs that you can't transfer. Badges was another word. So this is written into ERC 721. It's called a read-only NFT registry, which does not sound nearly as fun as soulbound token. It just says always throw from safe transfer, approve, or set approval from all. If the only technical thing you're bringing to the table is not transferring things, this has already been standardized, and it's already in ERC 721. Now, on this phone call, we also talked about soulbound fungible tokens, like a score or a rating. These are really interesting concepts too. We went into this in several episodes. We also talked about negative numbers. So this mechanism, you don't need to standardize this. It's already written. I got it on the screen right now. So there are more things you could standardize. For example, externally owned accounts. Many people will say, well, I'll just wrap the damn thing and then I'll sell the wrapper. This is a well-known concept to people that build these tokens, and we are always thinking about robots and adversaries for whatever strategy we're making, right? Well, why don't we just restrict it to an externally owned account? Now, there's a couple ways to do this, and I think this is where you might standardize it, but honestly, more importantly, you just might build it into your product. There's a couple ways to do it. If somebody is using your smart contract, you know they're an externally owned account, you use tx.origin. Once that person has retrieved a token, they can continue to retrieve more tokens. You can use signed messages. So this is an approach where if you have a signed message that you know is an externally owned account without them spending any money by signing a transaction.
It absolutely does, and I'm glad you said that, because that's actually exactly how we built ours. And we've been talking to some people, but somebody was very vehemently against that because they wanted to use smart contract wallets. Like, they wanted to be able to issue soulbound tokens to smart contract wallets. It kind of conflicted with our model of consensuality, which is what we'll get into in a little bit here. But this is exactly what we do. We basically just say that every single time you try to mint the token, we call them claims. It requires a signature and a message from the user. And that way we can guarantee that, yeah, it's at least there's somebody there signing something and it's not like smart contract wallet.
It's not possible in that system to receive a token unless the person wants to receive a token. Now we've got some more options here. We can get a little fancier. We can take any transaction from that person. A transaction is simply a signed message of a specific format. Messages and transactions are the same thing. They use the same cryptography. You can take anything that person has ever signed and you can provide it to your smart contract, and that can be confirmation that this is an externally owned account. You can have any transaction from that person on any chain/network. So it is possible on Polygon, which knows nothing about Ethereum, for you to prove that an account is externally owned without them signing a message, without them providing a transaction, or even knowing anything about your product.
But they're still restricted from using, like, a smart contract wallet wouldn't be allowed to receive a soulbound token in that scenario, correct?
That's correct. There's a fundamental choice here. Allowing wallets, allowing wrapping. That is the choice. The problem is soulbound tokens, people, they have opinions on whether this thing should be done one way or another way. The word's kind of dead at this point. You might even call these non-wrappable tokens because everybody agrees that a non-wrappable token cannot be given to a wallet. Whereas if you say it's a soulbound token, then people disagree on whether it can be given to a wallet. You don't have to make this like part of your product name, but so when you're in your about page, you want to explain it that way. These tokens are not wrappable, and therefore we're not allowing smart contract wallets to own these things.
From just your standpoint, how do you feel on that? Do you take a side of the fence on if soulbound tokens should be issued to smart contract wallets or not?
Really, you're getting into a product decision. So the question is, why are we giving out these tokens? Are these tokens representing people? Are you going to use them as badges? So we're looking at, if you're a school and you give a token to a student, is that student an individual? Is it possible to give a token to an entity? Can I give a token to a smart contract? Can I give a token to CryptoKitties? Can I audit CryptoKitties smart contract and give a token representing that audit? These are all the questions that need to be decided at your product.
Sure. Yeah. And I think this also speaks to one of the other questions that I had of, like, is this something that's worthwhile for standardizing? But, if there's a different use case like you just described here, I would say that it probably is purely just a product thing. It's not something that gets standardized. It's up to the people that are building out the soulbound token solution to determine which route they pick.
Right.
What if we can use soulbound tokens for many aspects of proof of personhood? For example, I am working as a maybe PM, but I have more than that. I am a plant lady. I like watercoloring. Many traits are included in me. And maybe some communities can issue different credentials based on my proof of work, like literal proof of work or proof of expertise or proof of reserve, whatever it is.
Yeah,
definitely. And kind of more where our head is at with Soulbind, where we're looking at issuing proof of personhood, proof of work, credentials, achievements, things like that. Things that we think belong to a person, and also things that we believe require consent from the person based off some of the other functionality, some of the other features that we have within our app. But I think that that's an awesome use. I love the use case.
Can you tell us a little bit about what's your revenue model, open source or not?
Yep, we're open source. We actually provide gasless transactions. across the board for everything. So when you go to our application, you can create kind of like what we're calling a shell of a token, and this is a transaction that actually happens on chain. Very similar to Pope, if you're familiar with that, where like you go and you put in all the information, and then you can like unique codes or link or wallet addresses. From there, somebody else will come and claim that token. Based off of the data that the creator set, they set a whole bunch of different things. One, in particular, one of them is called burn authorization, and that determines who's going to have the power to burn this token later. A lot of organizations, like, after I issue this token to somebody, I want the power to pull that back if I need to. We present that to the user. The user sees that. They see what the burn authorization is. They see if the token is updatable. They see basically everything. And by signing a transaction, they're providing consent to say, yeah, I accept that I want this token dropped on my wallet. We do the transaction for them after they sign it. We pay for all that. Super user-friendly experience. They literally just click a button and then they get a token in their wallet. They don't have to worry about Ethereum or Matic or anything like that. The revenue model for that is we charge per claim. So like for an organization that wants to issue these tokens to people for credentials or achievements or whatever, they pay us per claim.
And do you batch them or you do them right away?
We batch them. Yeah.
Cool.
So I would like to in the future get to a point where we do it right away. We're just doing stuff that doesn't scale right now. We just batch it at the end. That's
a great product. You're saying these are different token contracts per project?
So I would love to get to that point. And this is part of the reason why I wonder if, why we think so much about standardization for this, because we're working with this contract and we're modifying it as we go. And I would like to get to a point where it's like relatively stable and we're like, this is kind of what it's going to be for a while. And then we can release new smart contracts for every single organization that comes to us. For right now, it's all under one contract. And so go to OpenSea. Yeah, maybe it looks like a little bit similar to Pope. You go to the Popes and all these things like a gazillion tokens, right? Ours is the same way. I would love to make it so it's like each organization gets their own spun up. It's infrastructure nightmare to like manage open contracts and upgradability. Like when we release a new feature, like we just released a new feature called drops. So like if you have the proper burn authorization, you don't need consent. You can drop out addresses as long as that user can burn the token at a later time. Releasing that new feature to all the other organizations' smart contract, releasing a new smart contract is just a little scary. We're going to get there, but I would like to have contract kind of leveled out.
Very cool. One specific feature we were thinking is that if you were to have a token, this token should be chainless. Yes, you could claim it on Ethereum if you wanted to, but you could also claim the same token on Polygon, Optimism, or whatever. The token itself, the essence of the token is not on chain, it's the message. It's the signed message. Once it's signed, it can be played anywhere. It can be played by anybody. So in your model, you're taking revenue for gasless. In this model, it could be the same thing. And then years later, they decide they want to migrate it to a different chain.
Do you need abstraction help for that? Just a brainstorm abstract idea, not the technical help, the concept idea initiation. I can think through to navigate through different blockchains. This, same message idea.
Yeah. We've got actually some notes at the top of this file here. We call it our airdrop DAO, thank you token, points. We have no idea what to call this. This is going to happen. You're going to do it and we're going to do it. Maybe we'll do it together. Maybe we'll have competing products or different models or whatever. But we're all thinking about how do we recognize people? What do we want to recognize? You and I were already thinking how can this go wrong? Which is kind of weird because we're kind of making positive things. It sounds like you're making something that's consensual. So it's already not like complaint tokens. So they're two-way consensual.
The vision for this was that we wanted to have both parties be giving a green check mark for this token to even live on chain, for somebody to actually say, I have this token. Because there's a lot of weight behind it, right? So with burn authorization, there is actually a standard for burn authorization. It's ERC 5484. When you set that, you either set it as, who can burn this? Is it you, the person that's giving this? Is it me, the person that gave the token to you? Is it both of us? Or is it neither of us? And depending on what those are, it's really, really important to get consent from the person receiving that token, because if it's a neither or only I can burn it kind of thing, and I'm just shipping these tokens off to you, I think that's a terrible ecosystem. We would be developing a terrible, terrible system. And I think, we've received some feedback that why are we doing it this way? Because people are going to drop tokens on people anyways. And I'm like, we're just trying to make the world better. Just because people are going to do it anyways, doesn't mean that we shouldn't try to make the world a little better and have some consent within the system.
We had talked about this and we had a different solution. We were considering that anybody could drop a token on anybody. And in fact, it would even be permanent permanent the way we were looking at it, unburnable. However, the real concern here would be spam. So anybody's spamming tokens on anybody. The solution we came up with was, yeah, there's going to be spam, but by default, you're not going to see it. You would only be seeing the tokens that you care about or from people that you care about. Whatever those people have to say that you care about, you're going to see it. It's almost like subscribing to a message flow.
Sure. Yeah, and I see the value in. I mean, OpenSea does something similar, right?
What that's different is because OpenSea decides which ones are spam or not. But on WeChat, the world literally doesn't exist except for your friends. There's nothing except your friends. And your friends' friends that you don't know, they don't even exist. WeChat it's very different than Twitter. It's a different thing. So there's zero spam unless your friend introduces to you the spammer. We were thinking about that. Personally, I think there's a lot of risk and a lot of centralization when somebody decides what the spam is. There's nothing wrong with that. I mean, OpenSea probably does a great job, and they probably have a phone number that lawyers answer when you try to sue them or there's a problem. I don't want to be in that business. I don't want to be in the moderation business. I don't want to decide. I don't want to have lawyers calling me. I don't want to hear about copyright complaints. I want nothing to do with any of that because this is a fully open source, zero revenue project that I'm going to deploy once and is going to live forever. Unlike OpenSea, where they have the keys on a lot of stuff, and when you have the keys, you get the phone calls.
Even though you and I are kind of building two similar but different things, is that we still provide the power for the users, right? We aren't the ones that determine what's the spam. They are. They say this is spam. I don't want to accept this token in our model. And in your model, they say, I only want to show these 5 things or whatever, right? It sounds like.
Yeah.
Which is, I think, a better way to do it. When I look at OpenSea's thing, it seems like a headache to even develop that. Our tokens, when we start creating them, they get dropped in the hidden thing, right? And it's like, oh man, now I have to reach out to OpenSea or something. I don't know. It's just a mess. I'd rather not have to deal with that. So cool. How do you feel about the consensuality that I described there with like burn authorization? I mean, it definitely sounds like you guys are going a different route with it, but just from a generic level, how do you feel about that?
Briefly, I mean, it's not bound. Is it bound if you can burn it? I don't know.
That's a good
I think you
question.
have to ask, what does soul mean?
Yeah.
I think it's a good question to be like, does a burnable token equate to a soulbound token? I think in my mind, I was thinking that as long as it's not transferable, it's bound to your wallet, soul, if you want to call it that. But, it's bound to your wallet. But I do, maybe there's a little hazy on if it's bound, if you can burn it. But I feel like giving users that ability to burn it is potentially important.
What if we kind of make it more immutable? Can we do that? Can we override instead of burning it?
Another thing that we were worrying, should we let our users increase the token limit, tokens or credentials that they create? Because it might be a great user experience to provide that, but what are like the implications of that you think would come up?
Token limit quantity?
Yes, exactly. So for example, we go to the use case of company X creates 10 credentials for their 10 first users, and then they issue those, and then afterwards they have the ability to actually say like, okay, but we want to create 100 of those for the 100 first users. There might be cases where the first 10 would have thought, okay, we thought there were only 10 credentials, which means this was like a more rare credential to own, and suddenly there's 100 of them. There's a lot of cases where this is great, provides a lot of like flexibility and a great user experience for people. But in other cases, it might feel like something that some people won't expect.
Personally, I like to be very clear up front and to not have changing rules. The way you guys are building, I would have, at the time that you're creating the batch, I would set in stone whatever it is that you want to set in stone and not change it. So you're probably billing at the time that you're creating the batch.
We're actually billing at time of claim whenever a mint occurs.
So the burning is done at their own expense.
We still provide a gasless transaction for that.
Ooh.
The contract, they won't do, but our app provides gasless transaction.
Okay, that's cool too.
Thanks for explaining that. Andrew, do you want to go into that?
I think I would like to add a little bit of detail also on top of that. We do have another feature that provides updatability. When you're creating that shell of a token, that token event, put in all the metadata. There's a toggle on there that you can toggle to say this is an updatable token. One of the use cases, I can maybe dig into that to help reason why this is a thing. We have users that are going to be having their customers, their users, going through educational courses, right? And so like a user goes through a course, gets taught yada yada about the course, and they get issued this token. And it says that now level 1 or when they learn this skill set. 2 weeks later, they come back, they do another course, and now they're level 2. And they don't want to issue another token. They want to just update the original token. And what we're doing is we're actually updating the metadata of that original token for that particular, right? So the shell stays the same. You have this generic, like everyone starts at level 0, and that gets issued to people as they complete the first course. And then after the second course, they get leveled up.
I don't like that model. A couple things. You consented to the first token, so now you're going to have to consent to the token change or not consent.
There is no consent on the update.
So that's weird. Most games don't work that way. Most games have a trophy shelf. So you have a level 1 token and a level 2 token. So Stack Overflow, I have all kinds of badges and tokens. And so I have the bronze token asker and the silver token asker. And the bronze, you're like, everyone's got this. I've got like 12 of them myself. And then the silver, I've got 1 or 2. These are rare. We're going to invite you to parties. Do you lose level 1 status when you go to level 2? When's the last time you opened Airline's reward program and it's, okay, well, level 1 people get this. Level 2 people don't get that, but they get something else. It's never. It's every single time it's level 1 gets this and level 2 gets benefits as well as always like that.
Sure. Yeah. No, that's a good point. I think it makes sense to provide like historic. So the way we're doing it is pretty flexible and dynamic. We're just allowing them to modify the attributes, and the attributes is where this gets stored. We could prevent the original levels from being erased. Right now, we're just allowing them to do whatever. They can add a level 2 and a level 1 attribute if they really wanted to, but we could add some product level hard-coded restrict to say, if they were level 1 stays in there. You cannot change that. You have to, you can add, you can't modify the existing.
Yeah. So the last topic, ticketing, great use case, really makes a lot of sense. You can actually do these tickets with the token or without the token as soon as you have a signed message, whether it's accepted or not. That is as good as cash, right? NFTs for ticketing makes a lot of sense. Ticketing for a live event, you just prove to somebody live. But ticketing for in a smart contract like a Mint Pass or something, we were thinking that if you have the token on Ethereum, well, you could still have the same token on Polygon because you could just replay the message because the message is all the proof you need.
So the user is paying for that transaction to like replay that message and put it back on or put it onto a different chain, right?
Could be anybody. You're saying user, but the sender, the recipient, there's unrestricted write access to blast messages.
Sure.
If you're on Polygon and you wanted to invite 1,000 people that achieved whatever badge, you would just play those 1,000 messages, and then you would have 1,000 messages on Polygon. They would all have, be whatever permissions that you want those people to have, like minting a token, and then those people would have that feature. And then new blockchains that we don't even know about today can do the same thing. There could be shards or side chains or Tron or whatever. You just go on Tron, the accounts are compatible, you replay the message. So now the message is a standardized format. We want to standardize these messages. In fact, I think message standardization is going to be more important than on-chain standardization of stuff.